which places they've got awards from. And in Mohan's case, it's easy because I've known him forever. Which companies has he worked at? IBM. That's it. That's all you have to remember. And so he's an evidence that IBM does something right. He spent his entire career there and had huge impact. And then for awards, you have to remember, what was the society? And the answer is all of them, right? So he's ACM fellow, IEEE fellow. He's an IBM fellow, and he's the member of national academies on 2 different continents. So he has sort of a very long list of accomplishments, and we're really happy to have him here today. He's going to tell us about the new thing, like the new hot button from Mohan, which is blockchain. And so look forward to finding out more about what that is. Thank you for coming.
Thank you, Mike. 1 second, let me put this on. All right. It gives me great pleasure to be here. I've forgotten now when I was here last time, probably 3 years ago, 4 years ago. Because I've known Mike, as he said, forever, and we used to be colleagues also for quite a while. This is something that I don't consider myself to be an expert on, actually. I've been working on it since about October of 2016. And I've been giving talks on it since April of last year. So, but unlike all the other topics I worked on, the number of invites that have come to me after I started working on this just is like unbelievable. So I've already given talks in, I don't know, 8 or 9 countries, I think, on this topic, and I was in Australia just last week. The important URL is the one at the bottom of the slide. That's the one that has lots of links to, PowerPoints and videos, and more importantly, I guess, links to papers and white papers, researchy kind of papers as well as white papers. So I highly recommend that you go there if you get excited enough, or you want to tell your friends that are not here that they should take a look at all the material. So there's lots of videos there. And even if I give the same talk in the sense of using the same set of slides, giving the talk twice, what I say winds up not necessarily being exactly the same. So even at the end of this talk, you might find it beneficial if you want to get more information on certain topics, to go look at some of the other videos. What else do I want to tell you? I think that's about it. So I have lots of material. So if I had all the time in the world, those are the things I'll be able to cover. I made the assumption that not everybody is necessarily a technical person even, or even if you're technical, that you haven't necessarily looked at blockchain at all. And even if you're a blockchain person, I'm hoping that you'll get something out of this talk. So I'm trying to address all sorts of audiences with this talk. And so if you are already aware of some of the things, excuse me if you find it somewhat boring. But I will give you the background. And I'm also hoping that given the recency of bulk of the work that's gone on, especially the work on private blockchains, where not too many of the mainstream databases or distributed systems people have been involved. I'm hoping that through my talks and my evangelization of especially private blockchains, a lot more of the more practical-minded people will get involved, not just the fringe people in both database area and the distributed systems area, and that they'll get to work on more useful things in this space than all the madness that's there with cryptocurrencies and Bitcoin and Ethereum and open blockchains, which I consider to be quite impractical. So I'm sure some of you are aficionados of those things, and we can have debates about all that. I've had lots of debates on this point with various people. So I'm very much in favor of private blockchains, and we'll get into the discussion of what those things are. You will see, if you carefully look at the slide numbers, that the numbers suddenly jump. So I'll ultimately post these slides, and you can then see the hidden slides also. So some of the topics that I mentioned here are covered in the hidden slides. but I don't have the time to go through all of them right now. So the whole thing got kick-started. The idea of Bitcoin, as was proposed by somebody with a Japanese name. Nobody knows who the real person is, whether it's just one person or multiple people, whether there is any connection to Japan or not to this Nakamoto name, nobody knows. If you want to have some fun, go read the Wikipedia page on blockchains. You will find lots of interesting journalistic pursuits trying to identify who this person or group of people might be. Of course, that was done in the context of what's called open blockchain, which is one where anyone, anywhere, without revealing his or her identity can participate. Pseudo-anonymous is the more technical term that we use to describe what the situation there is. It just leverages private key and public key, but otherwise, if you lose your private key, tough luck, you lose all the money that you have in your cryptocurrency account. And there's a lot of stealing and all sorts of stuff that's gone on there. It's not like it's solving the world hunger problem or fixing all the problems with fiat currencies, which is what a lot of the 20-somethings and the sort of the more libertarian kind of people are getting carried away with this whole thing. And I in fact say that's what a lot of people thought linguistic problems of society can be fixed by Esperanto, and we know what happened ultimately. And in the same way, fashion, it's not like there's only one cryptocurrency, there are a gazillion of them. So much for that being an alternative to, or replacement in fact, of fiat currencies and all the bad things that have to do with currency manipulation and conversion rates and all that. None of that is solved by this, by any means, although you will hear these people telling you all sorts of stories along those lines. What's the problem there? Because they let anyone, anywhere get involved, they worry like crazy about Byzantine behavior, where somebody could intentionally screw up the system. Say one thing to one person and just the opposite to another person, even though they are supposedly saying a true statement or whatever. And so they have this notion of proof of work, where they try to make people solve a math problem as a way of trying to, decide who gets to add a block of transactions. And they waste a lot of energy in the process, and this is the so-called mining, and this is like throwing biscuits at dogs that do some tricks. So if you happen to waste a lot of energy and win this competition, they throw a few bitcoins at you. This is the kind of nonsense that goes on there. This whole notion of creating something out of nothing or wasting a lot of energy and creating something called a cryptocurrency also fundamentally is something that I don't buy into. It has nothing to do with real world productivity or services or goods and so on. So at that fundamental level also I have problems with this whole thing. And I would rather have economists at the central bank and various reserve bank and so on deciding how many notes to print and things like that, even though there is no gold backing as it used to be. People think as a result anything goes, and that's not true also. In spite of all the hyperinflation in Argentina and it's like that, I would still have more faith in people with economics background doing things than you and I kind of geeky people deciding for the whole world what the right thing to do is. But it's also become a source for a lot of papers to be cranked out by even the theoretically oriented people and such. So we can have lots of discussion on all that later, but let me get on with the show. So there are many organizations across the globe that are working on various aspects of this problem. That has to do with security, consensus, databases, and on, benchmarks and such. All sorts of little to big organizations, both private and governmental kind of entities are interested in this topic. There's been a lot of developments, especially in the last 2.5 years or so, in the private blockchain environment. What is private versus public? In the private one, it's only a group of people who have a business need to collaborate with one another that get to be part of a network, a blockchain network. They have to be explicitly permitted to be part of the network. It's not like somebody has no other job to do and just willy-nilly comes and joins for the fun of it, which is the way it works in the case of open blockchain. The price of admission to this club, a particular blockchain network, is that you have to reveal your identity and get a certificate, and again you have private and public key and all that. So in this environment, as a result, Byzantine behavior is something that you don't have to be so worried about, because it's like, you know, Uber, Airbnb, and so on. Yeah, people can still try to get away with literally murder, but then sooner than later they get caught or whatever, and, you know, appropriate action is taken, because even if you and I, as users of some of these things, don't have all the background on the people, the drivers or the renters, the corresponding companies, Uber and Airbnb, do have lots of information. And so it's for that reason also that scalability and various things like that are much easier to handle. And in any case, this whole hypersensitivity to Byzantine behavior that has resulted in all this expensive, ultra expensive, which causes things like 7 transactions per second and 10 minutes for a transaction's outcome to be determined. And even then, it's probabilistic statement. It's not even a guaranteed thing, because it's possible that multiple people win the battle to add a new block of transactions, so there can be a fork in a blockchain that was until then a linear chain, and this causes its own set of problems and so on. So in any case, there have been many developments in the last couple of years. It's no longer the case that this is all just, you know, proof of concept kind of thing, or kicking the tires kind of state of affairs. There have been production deployments of private blockchains. As it says there, in February last year is the first time, as far as I know, that the production deployment happened. But it's still the case that, as you will see as I give more details, the way in which transactions are executed is more inefficient compared to traditional ways of doing transactions, which has been my lifeblood in my PhD thesis, as well as bulk of what I've done after joining IBM has all been in the transaction space. And so the point is that that first deployment is in an environment where private equity funds are being managed in an offshore island. And the important point being that the number of transactions is not that high, but the value of each transaction is high. So this technology is not there, and not likely to be there for dealing with the NASDAQ and New York Stock Exchange kind of transaction rates. Forget about your TPC benchmarks with millions of transactions per second kind of things that you and I might be you know, excited about or have been conscious about for a long time, or, you know, tens of millisecond kind of response time that the Web 2.0 guys have made it more like a norm compared to the sub-second or sub-2 second kind of response time that was the norm in the TPC-C benchmark kind of time frame. Since then, number of companies have gotten excited about this topic. US companies, European companies, even Chinese companies, which are a big deal. Since my appointment at Tsinghua University, I've been making frequent trips to China, and so I'm even more aware of what they're up to. Not that they publish their things necessarily in English. Bulk of the documents are still in Chinese, and so initially, at least, a lot of these Chinese companies seem to be addressing the local market. They're not necessarily going after the rest of the world's market. So, for instance, Huawei announced just last month, or last month, it's already June, so it was in April, blockchain as a service. IBM has had it for more than a year now. It was initially based on the 0.6 release of the Hyperledger Fabric. Later last year, the first release of the Hyperledger Fabric happened, and that's considered like the really production-ready release. But even in the prior release, there had been production deployments, including, for example, Diamond management application called Everledger. I've heard the CEO talk about that whole thing, and I can get into it a bit later. The IBM offering, the one for which you have to pay money, even though the software is open source, It's a managed offering on the IBM cloud that actually runs on the mainframe running the Linux operating system, and it leverages some of the mainframe features like secure execution, where the code as well as the data that's being managed using the blockchain application and the base platform are all protected by any tampering or listening in by even the operators of the system and things like that. Some of you might be aware of the Intel SGX stuff. This is much superior compared to that because there aren't any limitations on how much memory and storage you can put under the secure execution enclave. And it also leverages hardware support for encryption and things like that. There are other companies like Oracle, for instance, has announced a service. It's not yet available, and that's also based on version 1 of the Hyperledger fabric. And Baidu, which is China's Google, for example, joined the Hyperledger Consortium. So you will hear me talk about how a lot of the work in this space, in the private blockchain space especially, is being done in the context of consortia instead of individual companies doing things. So at least in that sense, things are not as chaotic as in the NoSQL space, where it's essentially individual companies with their own weird APIs and this and that in a non-standard way, creating a new system every other day and things like that. At least here, the number of consortia is much smaller than the number of individual efforts that have fueled all the hoopla with NoSQL. So at least it's not as chaotic here as it is the case. But I have to emphasize that even during the relational starting days when Ingress was being done at Berkeley and SystemR in my lab, at least the conceptual model was the same, even though Ingress used Quell as a query language and my predecessors used SQL as the language. But at least the conceptual model as defined by CART was the basis for both systems. Whereas with these blockchain systems that are currently being developed and deployed in many cases, they don't even have a common conceptual model. And so to that extent, you better be careful if you're going to choose a system now. Do your homework and not get carried away by saying, oh, Intel is part of this consortium, so that must be the right one. Guess what? A lot of these players are not sure about which will be the winning horse or which small number of them will be the winning horses in the long term. So they are hedging their bets by being part of multiple consortia. So Intel is part of Hyperledger as well as the Enterprise Ethereum Alliance. So is, for example, JP Morgan. They're also part of both of these consortia and so on and so on. What else would I want to tell you? I keep revising these presentations. So just in the middle of last month, the Enterprise Ethereum Alliance released a new specification. For a long time, since it was announced as a consortium back in February or March of last year, to now, there had been mostly dead silence on the Enterprise Ethereum Alliance, which was the one that was trying to take Ethereum from the open blockchain space into the private blockchain space. Finally, they put out something, but it's still not quite clear exactly what's going on there, because for a long time I used to say that the basis for EEA is Quorum, a system developed initially in-house by JP Morgan, which they then open sourced when the alliance was formed. And I thought that was going to be the defining thing, and I used to go around giving talks that way. But since then, in the last few weeks, I've been corrected that there's been some chaos on that front, both within JP Morgan, where they were not sure what they were going to do with Quorum, because the original developers are not there, and also even the EEA, the executive director and so on were missing in action for a while and things like that. So we'll get into that discussion later. There is more detail here about how, in the case of Bitcoin and similar systems that are based on cryptocurrencies, things are done, what the conceptual model is. It's somewhat like Petri nets, where you have tokens flowing in and then tokens flowing out. Here, the tokens represent essentially money, the cryptocurrency, and they also have to think about making sure that the number of incoming dollars or whatever it is, Bitcoin, is the same as the number of outgoing ones, except that at some point money has to be created. And so they have this notion of Coinbase Transaction, which is the one that creates new coins. And that's part of this throwing dog biscuit kind of thing that I mentioned, which is where they create the money. And then there are more things here about exactly how you define ownership and things like that of the cryptocurrency, and that's all based on this private key that I mentioned. What else? So you send money from one person to another by essentially making use of the address of this person that you are sending the money to. But that address still doesn't identify in the real world who the person is. Yeah?
Do you have an idea of what money has actually been lost because people use
In fact, I was reading something, I wish I had made a copy of it. In the last few days, there were some press reports that I saw. I have no idea. I mean, people talk about even billions of dollars and things like that, but I don't know. But there has been definitely a lot of stealing and such that's happened.
So you mentioned something about performance up front, and you said the thesis before.
Yeah.
Is there a sense for where performance is going with?
Well, so what I mentioned to begin with, Nalini, was the open blockchain performance, really bad. The private blockchain, the IBM guys wrote a paper recently. I don't think it's been published, but I have a link to it. April is the version 2 of this paper, 22 authors. There they simulated using the Fabric version 1.0 Bitcoin, and they report something like 3,000 transactions per second. Okay, so that's still better, because it's not worrying about Byzantine behavior and such, and it's in a private domain, right? So it doesn't have all the scaling issues, having to wait long enough to see whether your transaction happens to be in a block that's in the longer chain and not in the shorter chain and things like that, which is what's primarily the reason for that wait of 10 minutes before you know the outcome of a transaction, or you in an asymptotic sense assume that your transaction is likely to ultimately succeed.
The other place where real money is lost is energy.
Oh yeah, of course.
Dwarf any kind of bitcoins that are lost due to compromise.
Yeah, in fact, I can say stories about this. In the middle of Canada, the Canadian power generation company is having a hard time keeping up with some of these server farms. In China, of course, it's well known there are lots of server farms. TSMC has made extra money by building ASICs to do all this mining more efficiently. All sorts of stuff like that. The Applied Materials guys asked me to give a talk because they were seeing dollar signs just because TSMC reported that they saw an increase in their revenue. These guys were wondering whether they should also build something special. KLA, Tenco guys also made me talk to them and so on. So it's madness at this point. So let me also state one thing that I haven't explicitly said. So the blockchain itself is the data structure that's underneath the Bitcoin system, okay? So it's that blockchain data structure, the technical underpinning, that we are more excited about than the notion of Bitcoin itself. It's not like this blockchain itself is something revolutionary that came from nowhere. This paper actually gives you the long history of various ideas that had been developed since the early 80s, which got combined to ultimately come up with the notion of Bitcoin in 2008 or so by Nakamoto, okay? So you can go dig into this. It leverages things like hashing in order to, in a provable way say that somebody agreed to doing something, and this is still the untarnished version of whatever is the data that they produced. So it still relies on hashing, and so as you know, SHA-128 has been shown to be breakable. So people are now saying use 256. And of course, there's now a lot of concern with quantum computing that even such things might be in the not too distant future broken into. So subject to that kind of problems potentially cropping up, the general idea is that you want to track certain pieces of information in a way that it cannot be tampered with without being detected. Okay? So that's part and parcel of this blockchain way of recording information. You will keep hearing about immutable. Don't assume that just because people say immutable that everything that's being done is done in an immutable fashion. There are state databases which can be perfectly traditional kind of databases with in-place updating. It's just that the ledger that's kept separate from the state database itself, that is the append-only no in-place modification kind of data structure. And that's not too different from a traditional recovery log where we never do in-place updates. Recovery logs have always been built as append-only files into which information gets shoved. As you will see later, there are some differences between what gets recorded in a traditional recovery log versus what gets recorded in the blockchain data structure. Anyway, I'll come there. So in terms of what all technologies have relevance or related to what's happening in the blockchain environment, especially the private blockchain environment, a whole bunch of distributed systems technologies, and all of these sorts of things have been worked on during my own professional career of 36.5 years. I myself have worked on many of these things, especially distributed two-phase commit protocols and the messaging and queuing systems and workflow management systems, caching as in distributed databases, client server, and then of course later came things like cloud and having to worry about failures of different kinds, multiple data centers and so on. And then of course the private cloud, the hybrid cloud and things like that. By the same token, a little before I joined IBM is when the relational stuff was done in my lab. And then, of course, my own stuff started with RStar and things like that. And there have been lots of things like OLTP versus data warehouse, and more recently, of course, the stuff with NoSQL, MapReduce, and all this kind of stuff. And then, of course, data privacy, and right now it's a hot topic with things like GDPR coming into force. Even before, Europe used to be much more paranoid about trans-border data flow restrictions and things like that. Not as much in the US really. And of course disaster recovery and things like that. So you will see replicated data management has been around for a long time, even before relational databases got into it. Systems like Lotus Notes, which came out in late 80s, already had in a commercially available product fancy support for disconnected operation and conflicting updates. By no means is all this eventual consistency stuff just a new thing that happened after the Web 2.2 guys came into the world. They have been around for a much longer time. They might not have necessarily used the same terminology. And of course, things like stored procedures and all that are also very relevant in this context, as you will see. So what's the kind of problem scenario we are trying to deal with using the private blockchain technology in particular? Look at a scenario like this where it's an import-export scenario, and you have many players, importer, exporter, the trucking company which picks up the package and takes it from the exporter to the port or the airport, and the airlines themselves or the shipping company, and then you have other people like the customs people and such, regulators and so on. All of these guys might be using computers. They still use a lot of paper-based things also, and they might even be exchanging electronic messages, but they tend to be point-to-point, and there is no single source of truth. Each one has its own databases, and the programs that manipulate those databases are, for the most part, independently developed ones, and there is no overall business process with well-defined rules that govern the state changes that are being made to the assets that are being managed. And this leads to a lot of inefficiency, it's expensive, it's vulnerable, people still can do, crazy things like if somebody dies because the food got rotten and things like that, they can go change after the fact certain things to try to shift the blame to somebody else and things like that. The temperature in the truck and so on. And so what we would like to see happen is, instead of doing things in this way, where in some cases there are also intermediaries like clearinghouse, or in the case of house purchase, you have escrow companies and things like that. You want to move to an environment here where there is a defined set of programs that are executing in all the nodes that are part of this business process, and they are all essentially doing updates to the same database state, but in a replicated way, in a parallel way. And in addition, you're also having all these digital signatures, encryption, and leveraging of private key, public key, and things like that, so that later on, after somebody had agreed to doing something, they cannot claim they didn't agree to it. Okay? So that's the general idea, and this then leads to carefully tracking who did what, when, and such. So provenance can be more easily dealt with, and also this immutability that has to do with the blockchain data structure in which you are recording all the transactions that are happening. And in so doing, unlike a traditional recovery log, you also record what items were read in addition to what items were modified. And also, in a traditional recovery log, as multiple transactions execute, the log records of the different transactions get interspersed. Whereas here, at least in the fabric, as you will see later, each transaction is described in its entirety before the next transaction is described. So there are some such differences with respect to what goes into the blockchain versus what goes into a traditional recovery log. And so in figuring out whether or not different parties are in agreement with a certain state change that you are about to perform, there's a notion of consensus that is made use of. And that's where the proof of work was the consensus protocol used in the case of Bitcoin, and that has been the source for all that horrible performance and wastage of energy and things like that. Whereas here, you don't necessarily need to make use of such an expensive way of determining who gets to add a block of transactions. And also, it doesn't have to be that non-deterministic thing whereby multiple people can win that battle, as it's the case with many of these open blockchains. Turns out, all the ones that I know of in the private blockchain are ones where the chain is always linear. It doesn't have all this branching and so on. But we'll get into some of those details later. But before I get there, I just want to show you, the IBM blockchain as a service offering that I talked about, that has, as part of the IBM cloud, on top of the IBM cloud, the Hyperledger Fabric, which is the base platform that I've referred to already multiple times. In addition, a more recent project that's been done under the Hyperledger umbrella that IBM initiated by contributing open source, and now it's a community project, is the Composer, which lets you more easily develop solutions on top of the fabric, and I will tell you what it lets you do. And then you have the application itself, which is running on the client side. And then you have a few other things that have to do with managing the whole thing. And some of these sorts of things that are the vertical bars are IBM offering unique things that are not necessarily in the open blockchain, in the open source version. By the way, there's another confusion. A lot of people go around blabbering away things like, oh, open blockchain means it's open source, whereas private means it's non-open source. This is a total bogus statement. These two are orthogonal to one another. So, just like in a database context, you have application programmer, DBA, system admin, and so on. There are roles that have been defined in the context of blockchain applications. You have the notion of blockchain architect, which designs the blockchain model, if you like, and we'll see what the model consists of in a bit. You have the developer who writes the applications that runs on the client side, and you also have the blockchain network operator, which in this case is IBM. In the future, it could be Huawei or Oracle, for example. You also have the blockchain user. So in addition to members of the network being organizations, you have individuals within those organizations who are also there as users. So the privileges associated with these organizations versus individuals can be different and so on. And in order for such things to be defined, who is part of the network and so on, you clearly have membership services, which is where you get your certificate and things like that. And rules are defined as to who can do what and things like that. On top of it, in order to perform oversight, you might have regulators. This could be the SEC, FDA, and such organizations. In addition to all this, you still have traditional software that is there that might be in the domain of an individual organization. So an order might be accepted through the blockchain, but the fulfillment of the order might involve having to go make use of SAP or some other manufacturing system. And that means that you still need to interface with back-end transaction processing systems as well as databases and such things. If you now look at what the composer lets you do in this context, it is essentially like 4GL tools on top of a database system, which allow you to more easily develop SQL applications. In this case, it lets you define what the model of your particular use case scenario is. What constitutes a model? You have things like assets, which could be the diamonds or the packages or containers and such things, or food items in the case of a farm to fork kind of blockchain application, which is something that IBM has worked on with Walmart, for example. And for these assets, you have certain transitions you can do. In the case of diamond, it gets mined and then it gets sent for polishing, gets split into multiple pieces, and then it gets sold in bulk and then sold in retail. And then somebody buys an individual diamond, mounts it on a ring. All these are different state transitions that you can do on this kind of asset that you have in your particular solution. And then there is logic that implements these state transitions that then figures out whose agreement needs to be obtained and things like that. So that's the transaction and the transaction logic. And you have registries in which you record these assets, the transactions, and also the participants. Who the people are, the miners and the polishers and the guys who split the diamond and people like that. So this is the sort of model, which is like a database design in a traditional database system that you need to think about in this context. Remember I said, if you look at the old scenario where individual people developed separate applications that ran on individual organizations' nodes, and there was chaos as a result. So now, in order to benefit from this brave new world of private blockchains, it's not like you just roll in this new piece of software and suddenly the world will be a better place for eternity and so on. You do have to change the way things have been going on. So you do need to rewrite those apps in order to bring them into this fold, meaning you have to make them all do the same thing and things like that. So how do you do that? That's what this picture is talking about. In the case of certain situations, it might be the big guy who decides what the set of programs is that will execute in all the nodes. This could be, in the case of Walmart decides for all its minions that are its suppliers, it's going to determine what the blockchain program logic is, transaction logic is, and they all have to merely just go follow it by deploying it in their nodes. Or it could be a more democratic thing where everybody sits around a table and decides what the set of programs is. And there are lots of new things that you have to do in the sense that the programming languages that are supported might be restricted, and the functionality that you're allowed to use in these programs may be a lot less restricted. For example, in many situations, they want these programs to have deterministic behavior. So you might not be allowed to have access to RAL function and current time and things like that, because that could then, when the same program executes in multiple places on behalf of a single blockchain transaction, they might wind up getting different results, and that could be catastrophic. So there are a bunch of restrictions that have been placed in that context. And then there could be other situations where, for instance, the way a bunch of Canadian banks chose to implement a know your customer solution was to farm out the work to a startup called SecureKey, and they came up with the blockchain solution. And then these other guys, obviously the banks would have given the requirements, but the actual act of writing the programs was left up to SecureKey to do it. It's a startup that did the work. And there could be others where a bunch of big players sit around the table and decide, and then the little ones that are part of the network merely just use what these big ones came up with. In terms of application areas, they are all over the place. By no means are these blockchain applications restricted to only the financial domain. And we've already talked about Everledger, which is the diamond one. This Unigestion is the one that was implemented as a first production solution in the Guernsey Island. And IBM itself implemented with IBM Global Finance. And then there are these other ones which are not yet in production, like the Walmart one and the Maersk, which is the world's largest shipping company. There's a book that came out a couple of years ago, this father and son team. They characterized this whole phenomenon as the second coming of the internet. What do they mean by that? What they mean is that for the man on the street, not you and I as geeky people, this technology has the potential to have as much of an impact as the widespread adoption of internet brought to the common people. Okay? So the dad, of course, said, oh, you know, I'm somewhat hyping it, but then he rattled off for a whole hour. This was March last year at the IBM conference. A bunch of applications. And so I myself have listened to lots of application descriptions, even within the IBM context, as well as in external context, like the conference in Vegas and so on. So here are some more details. I won't dwell on them too much. This is the farm to fork application that was done in China between IBM and Walmart. More recently, a bunch of other companies have joined this. The idea clearly is to track food ingredients as they go through the supply chain, so that if something goes wrong, you can do more restricted kind of recalls rather than widespread recalls, and they expect to save a lot of money and things like that. This is the world's largest shipping company that I mentioned. Based on the original prototyping and such, IBM and Maersk have actually formed a joint venture now to take this forward and make it production grade. The idea, of course, is to increase speed and transparency for cross-border transactions that involve shipping containers and so on. Along these lines, the Port Authority of Singapore wants to get into the act of actually managing which ship a container will be sent in. They might have upfront decided which one it will go in, but based on the latest state of affairs with respect to arrival time and so on, they might dynamically determine that it's faster to send that thing through another ship than the originally intended one because the original one is delayed and things like that. Essentially, they want to minimize the amount of time these containers sit around in the port and take up valuable space and things like that. So instead of the shipping companies doing this, the Port Authority now wants to get into this. There are many, many such things that are being worked on. Governments are big time into trying to adopt blockchain technology because one of the points I forgot to mention before is the fact that there can be a lot more transparency because there is more careful bookkeeping done and that can be stared at by the appropriate people who have access to the information. And so the government of Dubai, for instance, wants to become paperless with respect to government work. It originally said 2020, now the new date is 2021. By the end of 2021, they want to make sure that if you are an Emirati citizen who walks into some government office, once you prove your identity with biometrics, because you have to carry a card which has your biometrics, the rest of the stuff about who you are, how much money you make, how many kids you have, whether you are married or not, and hence you are eligible for certain discounted or free services, blah, 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 all that is on the blockchain. That's the general idea. You don't have to carry anymore any of these other kinds of documents and this and that to prove all these other things. Abu Dhabi is equally eager to adopt blockchain technology, so there's like a competition going on. For those of you from India, Andhra Pradesh and Telangana are competing with one another now, neck to neck, with respect to who is the first one and widespread in adoption of blockchain technology. Indian government is also big time into promoting skills development and things like that. In the US now, IBM has been working with FDA The idea is to focus initially on oncology data, and they want to, with all the HIPAA regulations and this and that, more carefully track who has access to what information, whether the information that was provided with certain conditions is being made available only when those conditions are satisfied and things like that. And also they want to name these information leakers and things like that. Telecom is another area where this just shows you how, today when you are a CSP dealing with outside plant work in preparation for service to a customer building, there are many parties to such a thing, and each of them, as before, has its own database in which it's tracking stuff and things like that. But you now want to go into a mode of operation where using a blockchain, efficiency can be improved drastically and things like that, delays can be improved, and also more verifiable and things like that. So there are any number of things that can be done using this technology. So as I've hinted many times already, there are many consortia. Here is an incomplete list of them. The latest kid on the block was the EEA, Enterprise Ethereum Alliance, which came into existence early last year. The numbers are no longer the same. This information is really old information. And also, you shouldn't necessarily look at the number of members of the consortium to decide whether it's a successful one or not, because it's all a numbers game, right? Mickey Mouse companies, one-man kind of organization can give themselves a company name, some LLC, and then become a member. That doesn't mean necessarily that this represents something. But there's work going on everywhere. This is not an up-to-date chart. I have not been able to, from CB Insights, get anything more up-to-date. This is a year ago kind of chart. It doesn't show the US companies, and this includes both crypto kind of companies as well as private blockchain companies. These are startups and such that are very active, and as you can see, even in Asia, even in the developing countries, there's a fair amount of work going on. From a more technical perspective, this picture comes from the Sigmod paper last year by the guys from NUS. As you can see, there are various choices that you can have with respect to how the blockchain data structure itself is manipulated with respect to who gets to add a block of transactions, and that's where the consensus layer is there, and there are various algorithms like proof of work, proof of stake, and such. There's also PBFT, which is the practical Byzantine fault-tolerant algorithm. Here you have this contract execution area where there are different choices, and there are restrictions, as I said before, about what features you might be able to make use of. Some guys have defined their own languages as well as virtual machines and so on. And then here you have the database layer. In general, these systems, for various architectural features, made different choices. And they are not always well rationalized, justified, and compared and contrasted. So here is a place where you can crank out lots of papers if you're looking for a thesis topic and things like that. A lot of these systems are open source, and hence they think that they don't have to bother with rationalizing the design, writing it up, and things like that. This is a big time nuisance with open source. People think that gives them free license to not go through normal kinds of things that used to be done, which is like design reviews and architecture reviews and code reviews and such. A lot of times you ask some of these people, even my own guys, how do you do this, what's the semantics behind this, blah, blah, blah. They try to sort of explain, and then when you start drilling them more, the last resort is just go look at the code, as if it's so easy for anybody and everybody to look at the code to figure out what the thing was that the person had in his or her mind when she or he did something. I can spend many hours discussing all this, especially things like whether you keep all the information on the chain or you keep only the hash of the information on the chain, the actual information is kept in a traditional database. This is a favorite thing that everybody talks about because, oh, too much data might be there. They also say things like once you put something on the blockchain, it's there forever, and hence I won't be able to revoke it, blah, blah. In a sense, BS, because even in a traditional database, just because you deleted something, it's not like it disappeared forever. If you go into the recovery log, yeah, you can find when it existed, what the values were, and so on. It's the same sort of logic with the blockchain. The fact that in the state database, the object got deleted means, of course, it disappears from there. it happens that when it existed, when it was created and modified and so on, those versions are represented in the blockchain in some past blocks, right? That's no different from the recovery log having the same thing. So unless you purge the recovery log, you won't get rid of it even in a traditional database. So I have lots of issues with some of these people who very naively, wave their hand about some of these sorts of things. But there's comparisons to be made with how replication works in traditional distributed database environments. I don't have the time to go through that. There are benchmarks that have been developed. The first paper that came out was that Sigmod paper that I mentioned a minute ago. It's nice to write such a paper because now everybody who works on benchmarks will refer to this paper. This is Beng-Chin Ooi and Kian Lee Tan and others at NUS that did this work. Similar to TPC, they've come up with some ways of trying to figure out how, the application layer, the execution engine and such, the different components in the private blockchain space can be evaluated. And even though they said private, they actually wound up evaluating 3 systems and only one of them is private, and that's the Hyperledger fabric. So the exact results don't matter, it's just the fact that they've developed this in a way where you can plug in your own favorite system and all that, and then evaluate. And so they have similar to OLTP and OLAP workloads, and it's an evolving thing, and if you want, you can download it. More recently, the Hyperledger Consortium itself has defined a new project. It's a pretty recent one, like March, I think. And it has one university as well as IBM and other players like Huawei. So this is work in progress, just initiated. There is comparison to be made between Ethereum, Fabric, and Corda. I don't have the time, so let me just jump to, so what's the big deal with Ethereum compared to Bitcoin? Bitcoin was managing just one thing called this Bitcoin, right? Transferring money from different people, creating this Bitcoin as a result of somebody mining and winning the competition and so on. So Ethereum was the first one to generalize that to say, hey, let's use the smart contract notion to manage any kind of asset, be it purely digital asset like music recordings, videos and such, or digital representations of physical assets like diamonds and containers and so on. But it still had a lot of the problems of Bitcoin in the sense that they still use proof of work, and they created their own currency called Ether, and they also came up with this concept of gas for charging for the resources consumed. So it has many of the issues in terms of performance and such, but at least it came up with this idea of doing more with it than just managing this one thing. And Bitcoin has all sorts of problems. It doesn't even have a state database. Every time something is being checked for whether or not this transaction is valid, they go from the beginning and recompute what this money is that somebody has, whether the person owns enough money to even do a transfer and things like that, which is kind of stupid. Instead of having the latest state of affairs in a cache, they keep computing, and that cannot scale obviously after years of this thing working, or millions of participants in the node and so on. So at various levels, both technically as well as privacy, that basis, performance basis, all this is, in my mind, just not practical. So the more interesting thing was that Enterprise Ethereum Alliance, which was trying to take it to the private domain. And as I said, originally I thought Quorum was going to be the basis, but then there's been chaos there. Quorum basically has the idea that you can have in a blockchain network many participants, but some transactions might be restricted to only a subset of the participants. So they have this idea that, let me go to the next slide. Oh, sorry, I didn't put that slide here. Basically what they say is you have certain information that's public to everybody. So they have a public database, and then they have these private databases in which only subsets of the people have access to the information in the private database. But they still have only one blockchain, which is very different from the way Fabric works in this kind of a situation where the notion of channel has been introduced to provide within a network subsets of the people to have visibility to only their thing and not let anybody else see their thing. In this case, in the single blockchain, they have all the description of all the manipulations of the public data. But for the private data, they have only cryptic information. What that means is that if anyone's private database gets blown away, in order to recreate its contents, they cannot just go through the blockchain and reconstruct it because the blockchain doesn't have the details of this private stuff. They have to go copy it from somebody else. Whereas in the case of the fabric, for each of the channels, which are like in a Venn diagram, subsets of the members of the whole set, they have their own private state database, blockchain, and transactions. And as a result, their blockchain has all the description of all the data that's being manipulated. And so if a single state database gets blown away, you can just start from the beginning of that blockchain and reconstruct it, because that's like doing roll forward recovery from the beginning. This is just some more details of the EEA client specification that just came out a couple of weeks ago. I don't have the time to go into the details except to point out that certain features come from the basic Ethereum, and then there are extensions that are the ones in blue that have to do with the Enterprise Ethereum extensions. This is still what they call a client specification and a sample architecture, where I believe for the sample architecture they've used the quorum way of doing things. But it's still not clear exactly what this thing is, whether they're going to support only one architecture or it's a framework in the context of which multiple systems can be developed. So I'll quickly run through to describe to you a couple of slides, and then I'll just show some slides and stop. This is the blockchain, which is like a recovery system, recovery log, a sequential file. And then you have the state database, which contains the latest state of the assets whose historical evolution is described in the blockchain. Of course, within this database system itself, you can have the traditional recovery log, which has its own history of what all happened. But at this point, only the latest state is kept here. There's no reason why this cannot be a version database system, in which case even the past states can be there, and then you can do analytics on the evolution of the states and temporal SQL kind of queries. And then you have two very simple-minded indexes, which indexes into this. It's very simple-minded because all you can do is, if you're interested in an asset and you want to know who all modified the asset, it just points to those corresponding transactions. It doesn't say exactly what they did to that asset in terms of value-based way of doing indexing. And this just says, where are all the different transactions that you might be interested in finding out about? It just indexes into that thing. This is all baby stuff at this point. It's all, NoSQL, and that too awfully dumb NoSQL, which is key value store, which is even worse than pre-relational like IMS or VSAM or ISAM, where at least you have a primary key and then individual fields which you can refer to and manipulate and so on. Whereas here, it's primary key and then a bag of bits. It's all left up to the application, which in this case is the smart contract to deal with. How does a blockchain transaction start? The client invokes, and essentially this is like invoking a stored procedure with some input parameters, and that causes the smart contract to start executing, which makes database stalls get put delete because of this key value store thing. While it's doing that, it could invoke other smart contracts, but the net of all this is that by the time control is about to go back, which would constitute the end of that blockchain transaction, a bunch of database interactions would have been done. Ideally, we want all of those things to have been done in the context of a single database transaction. It turns out this execution to begin with is done in a simulated fashion, which means the gets go to the database and the results come back, but the puts and deletes are trapped by the fabric layer that sits between the smart contract and the database system. They just determine in an optimistic concurrency control scheme kind of way in a private workspace what the intended updates are. And they track exactly what got retrieved, which version of the data got retrieved. The reason for all this is when a client invokes a blockchain transaction, it actually talks to more than one node, the so-called endorsing nodes, which all have these smart contract installed. They all do the simulation, come back with the read set, which is the items read and the version number of the items read as representative for the actual value, and then they send back the updates that they intend to do. Now the client compares what comes back, and if there is agreement, then he proceeds forward by sending all that with the private key and all that, the endorsements, to the ordering service, which in this case is Kafka. So it's a very simple thing. It's not dealing with Byzantine faults at this point. This guy listens to and gets multiple such transactions, puts them into a block, randomly orders them, no logic used in being smart about which transaction goes first, which goes next, and so on. And then now sends this newly created block to all the nodes. These guys have amnesia after they executed the simulation of those transactions. They don't have anything persistent. They kept things in memory, and they send it back, and they immediately forget. So when they get it back, now they process this new block by going one transaction at a time. So awfully simple-minded stuff. That's why performance sucks, because there isn't enough leveraging of parallelism and so on, reminiscent of edge store and things like that. And what do? Pick up the transaction, get its read set, peep into the local database, check to see whether the state of affairs is still the same with respect to those items. This is the validation part of optimistic concurrency control. If they are the same, then without executing the smart contract now, they just take the right set and dump it into the database. This constitutes a successful execution of a transaction. If anything that relates to the read set has changed, then they just throw away that transaction. Essentially, that's a loser transaction. As you can imagine, if you have multiple such transactions which are manipulating the same item, then only the first guy will succeed, the rest will get blown away, and hence the performance sucks. Whereas in a primary copy replication, all of the transactions in such a scenario would have been executed one at a time. But they'll all succeed and they'll all get replicated. But because of this parallel way of doing things in this initial stage, these multiple guys would have read the same version of that object that they all want to modify. And hence, once one of them succeeds, in whatever random order the transaction got lined up, then the rest of them will get blown away because their read set will have a higher version number than what they read originally. And that's the problem. So there's more comparison of how these things happen. Then there are other systems like R3 Corda, which have their own conceptual model. They have this online, offline thing. They do support relational. They even keep historical tracking of the data. This is similar to the UTXO model that I talked about, because these guys targeted the financial industry, so they have something more specific that relates to such things. They even have notion of bond contract, cash contract. In addition to these state transitions having to be approved, the end states also have conditions that have to be satisfied. So there are more, these are like integrity constraints and things like that. Even transaction histories can be kept around and things like this. This is what I meant when I said, even at the conceptual model level, there's nothing common across these different systems. And then Intel defined its own project under the Hyperledger umbrella called Sawtooth, which leverages SGX. And they have just released the first release of this. And they do things quite differently and somewhat based on Ethereum. And they have defined their own, what do you call it? What's the word I'm looking for? Consensus protocol, which is POET, proof of elapsed time. Ripple had its existence long before blockchains came into existence, but they've now recast themselves. This was more in the foreign exchange transactions domain, one ledger to another ledger kind of transactions. Huawei has defined the cloud service. This is a repeat of that original slide I had. Parallelism, exploitation, and all that is a lot to be desired. What am I doing in my project? Replacing those silly get, put, deletes with more familiar, much more powerful, more error protective kind of language and semantics and such, including select, insert, update, delete, create table, call, stored procedure, and so on. In order to do that, I need to push more of this tracking of read and write sets into the DBMS rather than building a whole database layer on top, because today this fabric layer is cognizant of the API and their semantics and so on. Lots of things to be done. So if you're looking for thesis topics and such, here is some set of things that you could work on. And if you want to track more of this stuff, here are some points. Sorry, I exceeded the time.
So some of you are here for an official seminar, and this is co-hosted by the ISG group, and so you might want to remember the letters ISG is the secret code. And I want to let people just to state if they need to, and then
Okay.
So, hash functions like encryption is not being gracefully predictably. So, whatever you comment on how this would, even a private blockchain handle an tiny demise of a hash function.
So along those lines, even these smart contracts can evolve over time. So for instance, right now the Fabric does support the simultaneous existence of multiple versions of the smart contract, and it makes sure for any given transaction instance, all the nodes will execute the same version of the smart contract. Okay, so at that level, that's possible. Ultimately, like you are saying, whatever gets recorded in that blockchain, because the way they initialize a new node that becomes part of a pre-existing network is not by copying the state database from somebody else. Instead, they copy only the blockchain, and then they start from scratch, meaning from the beginning of the blockchain, and they roll forward. So in doing that, they still don't re-execute the smart contract, because they're still making use of the read and write sets that have already been recorded. But they do have to worry about anything else that could change over time, where they better capture, this is not too different from schema evolution problems in traditional databases, or if you have user-defined functions and such, and they could evolve over time, you have to appropriately tag version numbers and all that of such things. And that will include, if you're encrypting the data, this, that, and if you don't switch over to the new algorithm for all the data, when you switch the algorithm for the encryption, you'll run into the same problem.
I'm more concerned with hash functions because they are at the core.
Yeah, I understand. Yeah. I mean, clearly, these back pointers and such are, in addition to the regular pointer, page n pointing to n-1, it also contains a hash of that n-1 page. All of those sorts of things, yes, if over time these things could change, you better, as part of whatever you are recording, also mention what algorithm you use to compute. Yeah.
Good. Yeah.
What's that? I don't know about that, so I can clearly answer that question. I've spent very little time actually digging into these, what I consider to be esoteric things. So, hash graphs is another one that I've been told about. I haven't had the time to look at.
It's a very scalable
Work?
state
Okay. Yeah. In fact, I should take a look at it, because when I was in Waterloo a while ago, he had just been there, and so they were asking me questions about it. But I have at a more fundamental level problems with the whole notion of anyone, anywhere participating, ignoring even for the time being the performance implications of it. From a security viewpoint, even within a network where you have Walmart and Safeway and the suppliers for them, they were not happy if all of them could see all the things that are going on within that network. And hence the introduction of this notion of channel, whereby you might form one channel where Walmart and its suppliers are part of that channel, another one which has Safeway and its suppliers as a channel. There might be situations where even Walmart and Safeway are working together, in which case there will be a third channel that constitutes those interactions alone. But in general, this idea, I mean, transparency has its limits. Would you like to expose your bank account for the whole world to see, even if your identity is not known? There are many people who have now cooked up ways of even figuring out what appears to be two different people are in fact one person.
But even for individual blockchain, scalability is a problem, which hasn't been solved by any of the systems you described.
They have, because they don't have this idea of gazillion people being part of this one network.
Well, so that's avoiding the problem.
Well, no, it's not avoiding the problem.
How many
The
transactions do
the whole, no, sorry, let me just, the whole point of this is, as I said, jokingly, but see, it's really serious. Just because somebody has a computer, they just don't come to participate. In this private blockchain, you have a business reason to be part of this network. Otherwise, you have no role to play. So it's not an artificial restriction, it's a very meaningful restriction.
But the number of entities generating transactions is still potentially very large. And
It depends on your solutions, what your particular solution is. Yeah, I can imagine in a certain scenario, if you have a million suppliers to Walmart, then the question that comes up is, and I will discuss this by the way, not all of those guys need to be thought of as organizations because they don't have the wherewithal to run a whole node of their own, each one of these Mickey Mouse little farm and all that, right? So in such cases, the idea would be for a cooperative to be formed. These are very practical things that have been done in the real world too.
Creating hierarchies, right?
Yeah, exactly. Yeah.
Well, but, okay, so you don't have a solution for a very large system, so you create hierarchies. But there are solutions being proposed right now that seem to be dealing with very large number of users that are scalable.
But if that's intended to let anyone anywhere participate, then I still have a,
story. That's,
yeah.
well, how you use it is a different story, but whether you can handle 1 million users.
But also, the point still is, would all those people have to be participants in a given transaction? That's the other question to ask.
You have one ledger.
See, that's the problem. It doesn't have to be that way. That's the problem. So, whether the million guys will all have to have copies, see, even with all this efficiency thing, this whole idea that the way you initialize a new participant by going through the whole history is meaningless. Even in the private one, that's BS. I mean, they're just saying it today. People have already asked for even things like, what if your smart contract had bugs in it, which is very similar to traditional applications having bugs and screwing up the database. We have the notion of point-in-time recovery, where before you introduce a new version of an app, you take a backup of the database. And if you now let loose this new version and it clobbers the database, you say, oh shucks, I'm going to have amnesia now about what happened between the new version's introduction and the current time by restoring to that point. And then saying, wipe out the rest of it. This is all like anathema to the blockchain crowd, which says, once you put something there, but we've been asked for this functionality by the users of the Ibm blockchain as a service offering. You can't say compensation. Who's going to now hook up the compensating transactions for this messy thing that got done? So that's the other problem. Like I said, Bitcoin thinks for every transaction it has to recompute the whole story about the guy who is doing the transfer of money from one account to the other, one person to the other in that transaction. They don't even cache the state of the money owned by each of the parties at this point in time. This is all meaningless. I mean, what? Just because you can do it, that doesn't mean that it's good to waste a lot of energy and, you know, path length and everything. We all have been into efficiency forever with all our caching work and such things.
All right, I think we should probably stop because he's got a whole schedule this afternoon and he's going to get to eat. But